Hello and welcome. In this video, we're going to be solving a question related to kinematics that came in the January 2020 Mechanics 1 Edexcel exam. So let's start by reading the question. The question says, a particle P is projected vertically upwards with a speed u from a fixed point O. At the instant when P reaches its great height h above O, a second particle is projected. So what happens is there is a point, let's say this is O. One particle is projected, this is particle P, it's projected. When this particle P went up and it reached its maximum height, okay, so it reached the maximum height, which is h from O. Another particle, so this is P dash, another particle Q, at that instant when P reached its maximum height, Q was projected with a speed of half u over here. So let's continue the question. The question part A is for 2 marks. It asks to find h in terms of u and g. Okay, so basically let's think about P first. Let's think about particle P and let's see what do we have for P. So let's type in here for particle P. What do we have? Initial velocity, yes, we are given, it's capital U. I'm given that the displacement is h, okay, and I'm taking up as positive, so anything pointing upward, I'm gonna keep as positive. So the displacement is h above my original point, so it's positive h. My u is also, originally P was projected with a speed of u upwards, so it's also a positive value. I'm not going to put a negative u here. I'm going to keep it as positive. What else do I have? I know that v, the final velocity, when P reaches the height h, v is going to be 0. Because I know that v is going to be momentarily or for just one instant having a speed of 0 and then it's going to start to fall back down. What else do I need? I need h. No, I don't need h. I have u, s, v. I have acceleration. Obviously, acceleration is pointing downwards, okay? So I'm going to give it a negative value, and it has a value of g, which is 9.8. However, this question is interesting because this question literally doesn't give you any number. It's all variables, and it's asking you to get this in terms of that, and so on. So let's see what can we do. So from these four things are the important things for me: initial velocity, displacement, final velocity, and acceleration. Which quantity didn't I mention? I didn't mention time. So I'll use the equation that doesn't include time. In Saviot equations, the equation that doesn't include time is this: v squared equals u squared plus 2 times a times s. So let's do that. V squared is going to be 0 squared equaling u squared is going to be capital U squared plus 2 times a is negative g and s is h. Now I formed an equation where I can find h, make it the subject, and it's going to be in terms of u and g. So let's do that. So let's move the 2 times negative g times h to the other side. It's going to become 2gh equals u squared. It's a capital H over here. If I want h, I'm going to divide both sides by 2g. So h is going to equal u squared over 2g. And this is going to be my answer for the first part over here. So this is part A. Let's try and think about part B. So part B says, find in terms of u and g again, the time between the instant when Q is projected and the instant when the two particles collide. Okay, this is super interesting. Let's draw what's happening over here. So it says find the time between the instant when Q is projected and the instant when the two particles collide. Okay, when did Q get projected? From the beginning, we understood that Q was projected when P reached its maximum height. So our initial point, where when P is at a maximum height and it's having a velocity of 0, that's when Q started to project upwards. So Q is now projected upwards with a speed of half u. Okay, so what's gonna happen, this is gonna fall down and probably they both will collide over here. This is one scenario. This is scenario one. Or the other scenario is that Q is gonna go up and go down before P catches it, and they're gonna collide somewhere over here. These are the two scenarios, okay? However, this is not going to make a difference for us. Let's assume that the first scenario is the one that's happening, and let's base our calculations on that. So the question wants us to find the time, obviously from the beginning, from the start, like when Q was just projected, till the time they collide, the time passed for P until collision is the same as the time that passed for Q till collision. So let's call T, the time is a big T over here. So let's start by taking every single particle and writing down the quantities that we have for them. So let's start for particle P. And let's take this time down as positive, just to show you that you can choose whatever you want, down as positive or up as positive. So let's think about it. What's the initial velocity of P? It's going to be 0, because P is having a velocity of 0 at its maximum height. Okay? Right. Let me say that the distance from this level line, from point O up to the collision point, let me call it x. Okay, so if this distance is x, this whole distance is h, so the distance between P until the point of collision is nothing but h minus x. Okay, so let's keep that in mind. Again, let's get back to P. U, or the initial velocity, is 0. S, or the displacement, is going to be, for P, what's the displacement till the collision point? The displacement is h minus x, right? And h minus x, is it pointing upwards from the starting point or down the starting? Is it under or above the starting point? It's under. And we said that under, or the direction that's downward, is going to be positive. So I'm going to leave the displacement as positive. So I'm just going to call it h minus x. If I took up as positive, then over here I must come and do a minus sign over here to make minus h minus x. However, this is not the case. It's just for your information. So what else? I know that the time that's gonna pass for P, let's call it big T. Okay, time is important to me over here. Why? Because I know that time is shared, is the same thing between Q and P. Okay, so let's put it down. What else? I know that the acceleration is going to be gravity, and gravity points down. So do I put it as a negative g or a positive g over here? Try and think and let me know. If you said positive g, you will be right, because we said that positive direction is the downwards direction. So this is everything we have for P. Let's try to form an equation over here. So again, we mentioned U, S, T, and A. Which letter didn't we mention? We didn't mention V. So let's include the equation that doesn't have a V in it. And this equation looks like this. It's S equals UT plus half AT squared. So let's do that. So S is going to be h minus x equals ut. Okay, 0 times t is going to be basically 0 or nothing, and then plus half times a, which is g, times t, which is just capital T squared. So this is our first equation. Let's try and form an equation now for Q using the same exact ideas. And let's take for Q, let's take up as positive. Okay, so what's the initial velocity of Q? It was given in the question as half u. So u was vertically projected vertically upwards with the speed of half u. So half u. Do you think I should do this, keep the speed as positive, or I should put a negative sign? If you said positive, you are correct, because we took the upward direction as positive and Q was initially projected upwards. So what is S for Q? S is basically the displacement from here until the collision point, which we called as X. So S is going to be X. Time, again, is going to be capital T, and acceleration is going to be negative g this time, because we said upwards is going to be positive, acceleration of gravity acts down, so it's going to be negative. So let's do the equation over here. Again, we didn't mention v, so we're going to use this same equation, s equals ut plus half at squared. So s, which is basically x, is going to equal ut. So my u is half times capital U. My time is capital T. And then plus half times a, which is negative g, times time, which is capital T squared. So these are my two equations. And over here, I want to find the time in terms of u and g. So basically, I would love to eliminate x and h. For h, there is no problem. Why? Because we already found h in terms of u and g. So let's just erase this. Yeah. So h is u squared over 2g. So we can do that as u squared over 2g. Okay. Minus, I want to eliminate x. Why don't I substitute this x expression over here all the way inside this x, and this way I eliminated the x from the question and I can find my t that way. So instead of minus x, and I'm going to put in minus a big bracket, this x is basically this expression, so I'm going to put in minus this expression. So it's going to be minus, open bracket, half u t plus half times negative g times t squared. Let's simplify this. Okay, let's copy. We cannot copy. Okay. Okay, let's solve over here. So this is going to be u squared over 2g. Let's spread the minus inside. It's going to be minus half u t. Okay, this... Oh, okay, so this whole thing is h minus x. I forgot to do the equal sign, so we need to do the equal sign equals this part, which is going to be half g t squared. Okay, so now let's again distribute the minus inside. So this is going to be minus half ut, and then minus times minus g is going to be plus half g t squared, and this is equal to half g t squared. I can see from here that instantly half gt squared, if I move it to the other side, is going to become minus half gt squared, and this is going to cancel with this. So this whole thing cancels, and I'll be left with u squared over 2g minus half u t equals 0. So I can move this to the other side. I'm going to be left with u squared over 2g equals half u times t. And from here, what I can do, I can multiply both sides. So this is going to be 2u squared over 2g equals 2 times half is basically nothing, it's ut, and then I can cancel 1u from here and 1u from there, and then I will get my t equals, this 2 is going to cancel with this 2. I have only 1u on the numerator and g in the denominator. So this is my answer. My time is going to be u over g. So let's keep in mind that time t was equal to u over g, and let's read part C and try to find. Okay, so C wants us to find where the two particles collide. So where means what distance or what location. So we need to find the distance. So if we found x, it's going to help us determine where the two particles are going to collide. So over here, we had two equations, okay? And then we equated them to each other. We eliminated x. So what we can do is, now since we have t, what we can do, we can substitute our t into this equation to get our x. So let's do that. Let's do it over here. So we know that t equals u over g. Let's substitute that here. So x is going to equal half times u times t, which is u over g. And then plus times minus is going to become, let's do this, it's going to become minus half g, and instead of t squared, we're going to put in u squared over g squared, or basically u over g all squared. Okay, so this is going to equal, u times u is going to be u squared over 2 times g is 2g, and then minus half g into u squared over g squared. So this g is going to cancel with this g. So I'm going to have u squared over 2g minus 1 over 2 into u squared over g, which is basically the same exact thing. So I can find that u squared over 2g, this is all equal to x. So x is going to equal u squared over 2g minus u squared over 2g. So x is basically 0. So I found that my x is 0. What does that mean? That means that x, which is a displacement from here up to the collision point, is 0. That means that the collision point is actually over here. So remember the second scenario I told you about, when P started moving upwards, Q started moving downwards, but then Q reached its maximum height and started moving down before P caught it. So Q kept moving down and P kept moving down faster than it until finally particle P, which was moving down at this instant, and particle Q, which is also moving down at this instant, they caught up with each other and they collided at this position where x equals 0. So this is what happened over here. The different idea about this question is that you don't have numbers, you literally have only letters. So you need to know how to work around variables and how to solve simultaneous equations and so on. However, the idea of kinematics should be always there, that whatever the kinematics question is, list down all your variables, put each variable with the correct number or letter respective of their correct sign. So also take the correct direction into account, form your equations, and then try to get the values that you don't want. So forming the equations, I mean like choosing a Saviot equation to choose from or to formulate that will help you in what you want. Anyways, I hope this video was helpful. Thank you very much for watching. Please don't forget to leave a like, comment, and subscribe. Keep the notifications up, and I'll see you in the next video.